Hi ladies and gentlemen, today we're going to be going over some area mazes. All of these puzzles are from a book called The Original Area Mazes, Volume 2. So the puzzles will get progressively harder as we go through them. We're going to go through 6 examples, and the first one is on the page here. So right away I notice on the top we're given a length of 10 inches, and on the bottom part of it is 6 inches. The other part must be 4 on the left-hand side because the total has to add back up to 10 since opposite sides of a rectangle are equal. I should mention that all of these are rectangles. Opposite sides are equal. So the area inside is given to us. If the length here is 4, that means the width must be 7 because 4 times 7 gives an area of 28. So since the width is 7 inches on the left, that means the width is 7 inches on the right-hand side here as well. And we know the length is 6 inches. So that means when we multiply 6 times 7, it gives us an area of 42. So the solution, 42 inches squared. All right, next puzzle. All right, for this next puzzle, we're trying to find the area of the top rectangle there, the shaded rectangle. We know that the length is 4, but we don't know what the width is. We know that the width is part of this full length of 10. So let's see if we can use that and work backwards here. I see on the bottom here, this bottom rectangle here has an area of 42. Part of it, the length here is 3. If I bring this 4 down, that means the full length here is 7. Okay, 7 times 6, a width of 6, would give us an area of 42. So that means this left piece has to be 6 inches, which means the top part of this has to be 4, since 6 plus 4 adds up to 10. Let me erase what I have here so you can find the area. Okay, so since the length is 4 and the width is 4, the area of the shaded part is 16 inches squared. All right, on to the next puzzle. All right, this one is a level 2 puzzle. There are a lot of rectangles as I look at this, and I notice on the bottom we want to find out what that width is. Right, so we know the area is 36. We don't know what the length is here. We know part of it is 3, so that means we have to find out what this side is. To find out what this side is, we're going to have to figure out what this width is because we know part of it. So this puzzle requires a lot of working backwards. So we're going to start at the very top. Okay, so I notice here that the width here is 3. I'm going to bring that over. We don't need to know the length here. It's not going to help us with the following rectangle here. So I'm not going to bother looking for the length, but I am going to bring this 3 over to the side. And I notice this full width here is 7. Okay, so 7 times 5 would give us an area of 35. So that means this length here has to be 5. That means the bottom length must also be 5. So if this piece here that I'm highlighting is 5, and to the left is 5 as well, that gives a total length of 10. And 10 times 4 would give an area of 40. Right, so I know this right piece here has to be 4, which means the left piece here must also be 4. Going from the top all the way down to the bottom, we'll have, let me erase it here so you can see, we'll have a total width of 8 because 4 plus 4 gives us 8. So I'm going to bring that 8 over here on the left-hand side so you can see it. And a width of 8 and a length of 6 would give an area of 48. So if this top piece is 6 inches, that means down here is also 6 inches, which makes the full length from the left all the way to the right a total of 9 because 6 plus 3 gives 9. And 9 times what would give an area of 36? 9 times 4 would give an area of 36 here. So that means this missing width here is 4 inches. All right, next puzzle here. We have a shaded area that's kind of in the middle of these two pieces. We're given some information about the rectangle on the bottom and the rectangle on the right-hand side. So let's take a look at that. I notice that the width is 3 inches, and 3 inches times 10 inches would give an area of 30. We know part of it is 4 inches, so this other part must be 6. Right? So that helps us with the length in the shaded region here. So now let's take a look at the rectangle here that's on the right-hand side. We have 6 here and a 5 here, which doesn't help us here. We need to figure out what this missing piece is. So to find the width of this piece, we're going to take the area of 50 and divide it by the length of 6. And that's going to give us a value of 8 and 2/6, or 8 and 1/3. Right? So this piece here is 8 and 1/3. We know part of it is 5. So if I subtract 5 from 8 and 1/3, we're left with 3 and 1/3. So this piece here is 3 and 1/3. And the last step would be to multiply the length of 6 times the width of 3 and 1/3. So you have 6 times 3 and 1/3. So that's really 6 times 10 over 3. And I'm going to cross reduce here, which gives us an area of 20. Now, there is another way that we can find the area without working with fractions. So I'm going to show that strategy as well. So this next strategy involves cutting our rectangles into smaller rectangles. So I'm going to just add some markings here. I'm going to extend this line here as well. And we're going to work with the dimensions and areas that we're given. So I know the width here is 3, the length is 4. That gives me an area of 12 for the bottom left rectangle. The total area of that bottom rectangle before I split it was 30. So 30 minus 12 would be 18. So this rectangle has an area of 18. I also want to point out that this has a length of 3 on the left, which means on the right-hand side is also 3. We can bring those 3's all the way over. And on the top, you'll notice we have a 6. That 6 is going to come down to this length, and this length. So this 3 times 6 for the bottom right-hand rectangle gives an area of 18. So these two rectangles on the bottom have the same area and the same dimensions. That's helpful for us because that means this middle rectangle on the right will be equal to the shaded rectangle that we have on the middle left. So that's going to help us out. I notice on the top right, we have a length of 6 and a width of 5. That gives us an area of 30. And we know the whole thing there on the right before I partitioned it had an area of 50. 50 minus 30 gives an area of 20 left over for this middle right rectangle there. And like we said before, these two, and if I highlight them, these two have the same area. So that means our shaded one that we're looking for also has an area of 20 inches squared. All right, on to the next one. All right, so for this question, we are looking for the area of the shaded region here. Just by looking at it, I know I can solve a couple of things here. For the top left rectangle, the area is 21. The width is 3, so that means the length must be 7. I also notice on the bottom, we're given a width of 4 and an area of 28, so that means this width must be 7. I'm going to use some algebra here to help us, right? I notice this is 7. So if I label this with some variables, x and y have to add up to 7, right? They represent 7. And then I'm going to bring that down here as well. I also notice that y plus z has to also equal 7. So this top piece, 7, equals this bottom piece of 7. And I'm going to erase this arrow. Well, I'll leave the arrow there. We also know that the top piece is the same as x plus y, and we know that the bottom piece is the same as y plus z. Well, if I take these y's out, since they're the same piece here on the bottom, same value, that really means x is equal to x is equal to z. These two pieces have the same length, in other words. Okay, so then I'm going to partition this. That means this rectangle must have the same area as this rectangle because they have the same length and they have the same width. So let me pause for a second and just erase all my marking. Okay, so I've reset things here. I put my 7 back on top and on the bottom. I said that this x and that x have to be the same. Oop, sorry about that. And if the area on the left is 26, that means the area on the right is 26 since they have the same dimensions. Well, this larger rectangle on the right-hand side had an area of 39. And if I take that 26 away from it, right, that would give me an area on the top of 13. So this top rectangle has half the area that the one just below it has. Since they have the same length here, that means this rectangle here that I'm pointing at must have double the width that the top one has. Since the top one has a width of 3, I'm getting it from the left-hand side and bringing it all the way over. That means the rectangle right below it must have double the width, and it must be 6. Right, so that would be 6 inches here. Okay, I'm going to do some more erasing now. Since we use this information to find out this length here. Okay. So we know this piece here is 6. We know this piece here is 7, right? Because opposite sides are equal. So I can find the area of this rectangle would be 42. 6 times 7, which is 42. And we said earlier that the unhighlighted piece there was 26. It has the same area as the one on the left. So if I subtract 26 from 42, it would give us an area of 16. So that shaded region there is 16 inches squared. All right, one more that's pretty challenging here. Let's take a look. So right away I notice this bottom right rectangle has a width of 8 and a total area of 56. So that means the length must be 7, since 8 times 7 is 56. I also notice here on the right-hand side that value is 6, so this must also be 6. And 42, area of 42 divided by 6 would give a length here of 7. All right, so I'm going to partition off one of the rectangles, this middle rectangle on the top here. Okay, so I notice here this full length must be equal to this full length because opposite sides of a rectangle are equal. Right? I know part of it is 7 on the bottom, and we know part of this top is also 7. So that means if they have the full length that is the same, I'm going to label that X, and this is also X. They have the same value. Also, I notice the area on the bottom, this 56, is double the area of 28. So since these X values must be the same, and this piece is 7, that means X is half of 7. Right? This X on the top here is also half of this 7. And again, since they have the same width, the area of this rectangle here must be half of this rectangle. So the rectangle on the left has an area of 42. If I take half of that, that would give an area of 21. So I know this rectangle that we created here has to have an area of 21. I'm going to find the area of this rectangle here by subtracting 21 from 39. So it has to have an area of 18. Well, we know the width is 6, So 18 divided by 6 would give a length here of 3. So based on that information here, I know this full length from left to right is 7 plus x plus an extra 3 inches. Right? I also notice on the top here, this is some unknown length y plus another 3 inches. And since this makes a rectangle, opposite sides would be equal here. So 3 inches plus y is the same as 7 inches plus x plus the 3 inches. Right? So we can get rid of these two. 3 inches on either side, just chop them both off. And we know if I highlight it, this y is the same as 7 plus x, or this 7 plus x. So now that I've proved that this top piece here has the same value as this on the bottom, that's really what's important. I notice that the width on the bottom is double the width from the top. So if the width is half on the top, that means the area on the top should be half of the area that's on the bottom here. So if I add up 28 plus 56, that gives a total area on the bottom of 84. And then my last step would be to take half of this area, since again the width is 4 inches compared to 8 inches, and they have the same length all the way through. I'm going to take half of 84, or divide it by 2, and that would give an area of 42 inches squared. So that shaded area on the top is 42 inches squared.